Sunken continents near Earth's core could unbalance our magnetic field. Continent-sized structures of mineral protruding from the lower mantle towards Earth's outer core may be contributing to an instability of our planet's magnetic field. The two odd formations, one under the Pacific and the other under the African continent, Africa, resemble each other in terms of seismic waves, so were assumed to have the same composition. Cardiff University geodynamicist James Panton and colleagues have now concluded otherwise, determining the two regions are made of different material and have different histories. If true, it could affect heat flow and convection deep within our planet in ways that could influence the way Earth generates its magnetosphere. Up to 900 kilometers or 560 miles high and thousands of kilometers wide, the two large, low-velocity provinces have puzzled scientists since they were revealed by seismic data in the 1980s. Research has since suggested that they're at least in part composed of former oceanic crust. It is fascinating to see the links between the movement of plates on the Earth's surface and structures 3,000 kilometers deep in our planet, says University of Oxford seismologist Paula Kohlmager. Millions of years of natural crust cycling mixed with what was once Earth's surface deep into the mantle. The resulting composition now covers up to 30% of the core, slowing the seismic waves geologists use to probe Earth's inner structure. Our models of mantle circulation over the past billions of years demonstrate that the large low-velocity provinces can naturally develop as consequence of recycling ocean crust, write Panton and team, arguing against competing theories that the anomalies arose from the collision with Earth some 4.5 billion years ago that led to the moon's formation. The Pacific structure appears to have 50% more fresh oceanic crust mixed through it than the African province, the researchers found. That makes for a greater difference in composition between the Pacific province and the surrounding mantle, not to mention a notable difference in its density. We find the Pacific large low-velocity province to be enriched in subducted oceanic crust, implying that Earth's recent subduction history is driving this difference, says Panton. The notoriously active Pacific Ring of Fire has consistently replenished the crust material, the team supports. In contrast, the region around African structure is not a geological activity. It's not active. So the older crust it contains has been more thoroughly mixed in, making the structure less dense. The fact that these two large low-velocity provinces differ in composition but not in temperature is key to the story and explains why they appear to be the same seismically, explains Kohlmager. The different temperatures of these two structures compared to their surrounding regions impact how heat dissipates from Earth's core, which in turn affects the convection in the core that drives our planet's magnetic field. The researcher suggests that the two mantle structures are not allowing the core's heat to escape evenly on both sides of our planet, they may be contributing to unbalancing the field that maintains our atmosphere's life-supporting qualities. Africa's large low-velocity province has already been implicated in the weakening of the magnetic field nearby. The researchers require more data, such as observations from Earth's gravitational field, to better understand the impacts of this deep Earth asymmetry. And the research was published in Scientific Reports. This is on Science Alert by Tessa Koumoudouros. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.